So lecture 13 is about linear functions, and there are many different types of problems that we'll want to solve. So I'm going to give you quite a variety of examples here. Um, so for the following two examples, let's give equations of the linear function f of x with the following slope and y-intercept. Now, the procedure for this type of problem is to remember that a linear function is going to have the following form. So linear functions are of the form y equals mx plus b, where m is the slope and b is the y-intercept. Or we could write it like this. So we could write it as f of x is equal to mx plus b. Okay, so in these two problems, I'm giving you m and I'm giving you b. So I'm giving you the slope and I'm giving you the y-intercept. So all we have to do here is just substitute these things in. Okay, so that would be, so m is negative 6, so negative 6x plus 4/3. Okay, now I'm telling you that you should write this as f of x, so we could just write f of x is equal to this, which is equal to this, which is equal to this, so that's good. For the next one, so f of x is equal to mx plus b. M is 0, so 0x plus 3/4. So this is just the function f of x equals 3/4. So it's actually a constant function, but that's still considered a linear function. As long as you can write your function in this form, we would consider that a linear function. All right, so now let's consider the following problem. So give the slope and y-intercept if 3x minus 2y is equal to 12. Sketch the graph using this information and give the slope of any line perpendicular to that given line, and also give the slope of any line parallel to that given line. All right, so several parts that we're going to have to solve here, but first let's start with this equation here. So this is a linear equation, as we've seen before. So we should be able to find a linear function, meaning we should be able to write it into the form y equals mx plus b, and then from that we should be able to determine the slope and the y-intercept. So let's start with that. So if 3x minus 2y is equal to 12, well, what we can do, let's solve for y. So in order to do that, let's bring the 3x over. So minus 3x minus 3x. We left with minus 2y is equal to 12 minus 3x. Okay, and then let's divide both sides by negative 2. And then y is equal to, so 12 over negative 2 minus 3x over negative 2. And then this is negative 6. And then this becomes positive 3 over 2x. Okay, so we have y is equal to negative 6 plus 3 over 2x. So this right here, the coefficient in front of x is your m, and this is your b. Okay, so the slope is equal to m is 3/2, so positive 3/2, and the y-intercept is your b, and that's just negative 6. Okay, so we solved that part of the problem. Now what do we have left? Well, we're asked to sketch the graph using this information, and let's do that first. Okay, so given that the slope is 3/2 and the y-intercept is negative 6, let's see. So if we index these by 1, so then this would be negative 1, negative 2, negative 3, negative 4, whoops, negative 4, negative 5, and then negative 6, the y-intercept is going to be down here, right? Where it hits the y-axis is at y is equal to negative 6. Okay, and now the slope is 3 over 2. But remember, the slope, which is 3 over 2, geometrically, this is the rise over the run, right? So what that means is if we go up 3 in the y direction, the rise, and then we go in the x direction, we're going positive 2, then we will have to go through this point. You see that the rise was 3 and the run was 2, right? And both of these are positive, so we're going the positive y and the positive x. And so now the line that goes through these 2 points will continue to do that same thing. You will rise according to that ratio, that slope. So that's how we encode the slope in the line. So again, remember, once you know a point and a slope, it'll actually determine the entire line. But it's nice to see that this point's on here. But you see if we go up 3 more and over 2, that point will also be on there, right? Okay, what else are we asked to do? Okay, so we were asked to sketch the graph using that information, so we just did, and give the slope of any line perpendicular to that given line, and also the slope of any line parallel. Okay, so so if you remember, perpendicular lines will have slope equal to -1 over the slope of the line that you found, the negative reciprocal, right? So that would simplify to -2/3, right? So we just swap them and negate it, okay? Perpendicular lines will have this slope, so any line that would be perpendicular to this one, right? If you want me to, sort of draw you one, what would that kind of look like? So perpendicular lines, there are infinitely many, but it will have this slope here. So let's say you're on this point. The rise would be -2, so we would go down 2, and the run would be, well, okay, so it's a little bit harder to do that one. So so the rise would be -2, and the run would be +3. So it would go through this point and this point here. And do you see, if you continue that these are actually perpendicular, right? They meet at a 90-degree angle. Okay, kind of neat. All right, what about parallel lines? Well, parallel lines are going to just have the same slope that we found before. So parallel lines will have slope the same, the 3/2. So if I come over here and I just arbitrarily pick a point, actually, so if I pick this point and I do the same rise over run, right, rise of 3, run of 2, you see that this is a parallel line, to L. So let's call this line L. You see it'll be parallel, but it has the same exact slope. So it has a slope of 3/2. So now let's consider examples where I give you the graph. So for each of the following lines, determine what the slope and the y-intercept is, and then write the equation of the linear function. So the y-intercept is usually pretty simple to find because all you have to do is just locate where the line is actually hitting the y-axis, intercepting the y-axis. So here, the y-intercept, which is b, remember. So usually we reserve b for the y-intercept. That's just going to be +2. And how do we determine the slope? Well, we use the graphical interpretation. So rise over run. Okay, so let me switch to a different color here so we can kind of illustrate this a little bit. But the change in, let's say that you wanted to go from this point to this point here. Okay, so in order to get from this point to this point on the line, what do we have to do? So here, the rise is what? Well, to go from here to here, that's actually -2, right? We have to decrease the y value by 2 to get to this 0, the origin. And then the run is what? Now to go from the origin to this point, the run is +4, right? So +4. So you come over here, the rise was -2, and the run is +4. So then that simplifies to just -1/2. Okay, so then, and you could label that over here. Okay, and once we have these two pieces of information, the m and the b, then that determines a line, right? So then we have an equation for a linear function. So the linear function f of x is equal to mx plus b, and now we just replace the m and the b. So this would be -1/2 x plus 2. Okay. Well, what about this graph here? So in this one, let's first start off by finding the y-intercept, where it hits the y-axis. So the y-intercept, which again is, we'll use b, is -2, where this line hits the y-axis is -2, and the slope, which we'll use the letter m, is the rise over the run. Okay, so let me switch to a different color here. So the rise over the run, let's pick another point on here. Doesn't actually matter where. I like to pick ones that are not going to, if I pick this point here, then the run will be an integer, but then the rise, you see that it's not sort of a point on the grid. So if you can pick points on the grid, it'll make your fractions a little bit easier to work with, to start out with. Okay, so it looks like this point on the line is on the grid. Okay, so let's determine the rise and the run here. So to get from the red point to the blue point, what do we have to do here? We would have to go +2 in the y direction, and then +4 in the x direction, right? So then that would mean the, so the change in y over the change in x here. The y is the rise, right, is +2. And the x, we're going in the positive x direction, so that would be +4. So then the slope here would be 1/2. Okay? So to go from the red point to the blue point, how would we do that? Well, we would have to rise 1, 2, 3. So the rise is +3, and the run is 1, 2, 3, 4. We're going in the positive x direction. So what is that again? So the rise is, right, +1, 2, 3 over the run. Remember, it's going positive because this is the positive y direction, up, and positive x direction is to the right. So that's 1, 2, 3, 4. So that would be +4. So then the slope is 3/4. Okay. So again, 1, 2, 3, and then 1, 2, 3, 4. All right, good. All right, and then now, what else do we have to do here? Well, we were asked to write the equation of the linear function. So again, switch back to red here. So f of x is mx plus b, and we determine both the slope and the intercept right here. That's m, that's b. So this would be 3/4 x, and then the b is -2, so -2. So in this next example, I'm going to give you the slope and one point on the line, and I want you to determine the equation of the linear function. So let's say that the point is 3, -4, and the slope is m is equal to negative 1/3. Okay, so we got to find the equation of the linear function. So what would that be? So f of x would be mx plus b. Now we know m already, so we just have to find this. So we need to find this. Find the y-intercept. Okay, now what information do we have? Well, we have m, but we also know that this point is on this linear function. So we can kind of substitute all this information in. So what do we know? Well, we know the following. If I were to evaluate f at x equals 3, then this is negative 4. That's what that point translates to. And m is equal to negative 1/3. So what we could do is we could say f of 3 is equal to negative 4, which is equal to this thing where we substitute in negative 1/3. So negative 1/3 x plus b. So what does this tell us? Well, you see, we also know that x was 3, right? So the input was actually, whoops, I erased a little bit too much there. So this is negative 1/3 times 3 plus b. Okay, so this is substitute x equals 3 and m is equal to negative 1/3 into the linear function. So the only thing that's unknown now is b. We can determine b. So we have negative 4 is equal to 3 over 3 is 1, so this is negative 1 plus b. So then we just bring this over, and so add 1 to both sides, and we'll have negative 3 is equal to b. And now we're done because we know b is negative 3 and m is negative 1/3. So f of x is equal to mx plus b is actually equal to negative 1/3 x minus 3. So now let's solve a different kind of problem where I'm going to give you 2 points. So find the equation or find an equation. There are many equations, so I guess it's not technically incorrect, but there shouldn't be an s there. So find an equation of the line that passes through these pair of points. So if we're going to follow a similar strategy to what we had above, here, what do we need? If we want to write out f of x is equal to mx plus b, right, where m is the slope and b is the y-intercept, you see, we're not actually given the y-intercept information or the slope, so we actually have to find both of those things. So what is the slope? So that's m, so that's the change in y over the change in x. So that's y2 minus y1 over x2 minus x1. So let's pick negative 5, and we'll subtract y1, which is 1, over negative 2 minus the negative 4. And then let's simplify this. So this would be negative 6 over 2, and then this becomes plus, so plus 4, so that'll be actually positive 2, and then that gives us negative 3. So now we can kind of proceed similar to what we did in the previous problem. So now that we have this slope, which is m, and we know that this is going to be a linear function, the linear function is going to be f of x equals mx plus b. All right, so we know m is negative 3. So we actually know at this point that this linear function is negative 3x plus b. All right, so we still need to find this. And how do we do that? Well, we know that these 2 points are on the line. that is satisfied by this function. So what we could do is we could pick either one. It doesn't really matter. Let's pick the first one, and let's substitute that information. So if we substitute in, the input is -4. So let's substitute -4, 1. What do we get? So if I substitute -4, then this will be -3 times -4 plus b, but we also know that this is equal to 1, right? So, right, -4, 1, our pair becomes this, and so we can figure out b from this. So this will be 12, positive 12 plus b is equal to 1. So then subtracting 12 from both sides, we'll have 1 minus 12. So b is -11. Okay, so now we have b and we have m. So then just substituting that in here. So f of x is equal to mx plus b, which is -3x minus 11. Okay, now in this example, again, I'm giving you the graph of a line, and we want to determine the linear function represented by this graph. So what we're going to do is name the coordinates of any 2 points on the line, and then use those 2 points to find the linear function represented by the graph. So we can pick 2 arbitrary points in here and use the procedure that we did up above. But if we actually pick the point that gives us the y-intercept, it will actually make it a little bit faster for us. So if we pick this point here, which is what? So that point is 0, positive 4. So 0, 4, this actually tells us the y-intercept, which is b, which is 4. Okay, of course you could pick any other points that you want, but if we pick that point, we immediately figure out b, so that's probably the best point to pick. Okay, and now at this point you can pick any other point that you want. I'm going to pick this point, but you can pick any point that you want on that line. I'm picking this point just because I think the math will work out pretty nicely. So the other point is 2, 0. All right, now we have b. And if we want to substitute this into the linear equation, f of x equals mx plus b, right? Y equals mx plus b. Well, we have b, but we need to find m. So we need to find this slope. And how do we figure out slope? Well, we have 2 points, so we can figure out the slope as that change in y over the change in x. Now you could actually figure out the slope graphically. We see that the rise is actually -4 and the run is positive 2. But let's see if that calculation matches up with our chosen points here. So if we do 4 minus 0 over 0 minus 2, then we get 4 over -2, which is the same as -4 over 2. And so then this is just -2. Okay, so what that's saying is that's our slope. So geometrically, it might look like it's not matching up because of the negative is going down here, but it does it does make sense. Okay, so we're decreasing y by 4 and then going in the positive x direction by 2. The interpretation for this being the same thing is you could say, well, I'm starting at this point and I'm going -2 in the x direction and then positive 4 in the y direction. So it just depends on your chosen initial and terminal points. But in the end, it doesn't actually matter. You're going to calculate the same slope, okay, which is -2. Okay, but I just wanted to show you how the graph and the calculation matches up. Okay, so then at this point, f of x is just -2x plus b, which was 4. And that is our linear function. Oh, maybe I should also label the point down here was 2, 0. Okay. And to see that that slope is also negative 2, do you see if we do if we're trying to go to this point here, the rise is 2, and well, okay, so to go from 2, 0 to this point here, we would have to go negative 1 in the x direction and then positive 2 in the y direction, which gives us negative 2. So in this example here, I'm giving you this linear equation, okay, and it's written in standard form. So remember, we kind of had a standard form for a linear equation, and it looks like this. So you kind of have the coefficient, constant in front of x plus constant in front of y equals constant term. And then from this, we should be able to answer the following questions about the linear equation. So let's find the x and the y intercepts. So how do you find the x-intercept? So the x-intercept, you remember that is where the graph is hitting the x-axis, right? So if you're thinking about your graph here, if you're hitting a point on this x-axis, then the y value is actually 0 there. So we're going to substitute y equals 0 into this equation. So what would we get? We'd get 4x plus 3 times 0 equals 8. So that tells us 4x is equal to 8. And then if we divide both sides by 4, this would simplify to what? X over 2. So that's the x coordinate. So the x-intercept is the point is 2, 0. Okay? And then the y-intercept, now if you're just saying the b value, then that would just be the y coordinate, right? But here we're substituting x equals 0, because if you're trying to find where the line hits the y-axis, anything on the y-axis, that's where the x coordinate is actually 0 there, right? So we substitute that in, and we'll have 4 times 0, which gives us 0, plus 3y equals 8. So we have 3y equals 8. So then both sides we divide by 3, and so we get y is equal to 8/3. And so then the point, the y-intercept, is 0, 8/3. And so that value there, if we were trying to determine, what b is, that would be the b, okay? But when we say y-intercept, are we talking about the point, or are we actually talking about that b value? So I guess it's good to specify the point unless you are actually going to use the b value for something else, okay? Now for the next part, it just says to find a solution to this equation other than the intercepts in part A. So essentially what they're just saying is substitute something else and get another solution to this, okay? Another point. In other words, find another point on the line, right? So these 2 points are actually on that line, right? So you can pretty much pick any x value you want. Maybe we'll pick x equals 1, because if this is a linear function, there's no restriction on the domain. So I'm going to pick, let's try x equals 1. So if x is equal to 1, then we'll have 4 times 1 plus 3y is equal to 8, and then hopefully we'll be able to determine the y coordinate. So this is 4 plus 3y equals 8. So subtracting 4 from both sides, what do we get? we'll have 3y is equal to 4, and then divide both sides by 3, and so y is 4/3. So the point 1/4 is a solution, right? i.e. the pair x equals 1, y equals 4/3 is a solution. Okay? So that point is also on the line. Now, if we want to write an equation for the linear function, all we have to do there is just solve for y. So we have 4x plus 3y equals 8. We want to write an equation for this. Let's solve for y. So we would subtract both sides by 4x. You're left with 3y equals minus 4x plus 8. Divide both sides by 3. And then we will have y is equal to minus 4/3x, so separating this, plus 8/3. We could see that that matches up above the y-intercept. We had the point 0 8/3, and so 8/3 was b. And if you wanted to figure out the slope, you could do that real quick, and you see that it would be negative 4/3. Now, we have solved for y, but just to finish this up, we could say that that is f of x, just so we know that that's a function of x. But if you wrote y equals negative 4/3 x plus 8/3, that would be fine. But here we see that it really is a function. Okay, and then the last question is the point negative 3, 2 a solution to this equation? So what we could just do is substitute in this point and see if we get that it's a valid solution. So substituting in 4 times negative 3, because that's our x value, plus 3 times the y value, what do we get? Now, if it was a solution, we should get 8, right? But let's see what happens. So this is equal to negative 12 plus 6, which is negative 6, and that is not equal to 8. So this point is not a solution to the equation. And I'll leave it as a challenge to you to figure out if you had x equals negative 3, what is the correct y value? There's going to be a point on that line with x is equal to negative 3. All right, now the line L is perpendicular to the graph of this equation here, and it contains the point 2, negative 6, and we want to find the equation for L. So if it's perpendicular to this equation, then it should have the negative reciprocal as its slope. So we're going to use that to figure out the slope information. So this equation, what's the slope of this? Slope of this equation let's do that first. Okay, so negative 3x minus 5y equals 2. So solve for y, and you will add 3x to both sides. We will have negative 5y is equal to 3x plus 2. Divide both sides by negative 5. And we have y is equal to negative 3/5x minus 2/5, right? So separating this. So this right here is the slope of the line described by that equation, the equation line. So what does that tell us? So what is the slope? Slope of L is going to be the negative reciprocal of this. Okay? So what is that? That's going to be negative 1 over this value. So negative 3, sorry, this value, negative 3 over 5. So it's already a fraction. So just take the reciprocal and negate it. So it's actually going to be 5/3. And then, so now we have the slope. This is our m. Okay. Now we have to figure out, we have to find b, right? So now, we're going to have y is equal to mx plus b. And we know m is 5/3, so we have 5/3 x plus b. Okay, but we also know that this point is going to satisfy this equation, so we can substitute that in. Substitute 2, -6. Okay, and the only thing that we don't know is b, and then we'll be done. Okay, so substituting this in, x is going to be 2, y is going to be -6. So we'll have -6 is equal to 5/3 times 2 plus b, and now just solve for b. So we have -6 is equal to 10/3 plus b, and then we are just going to subtract this. So -6 minus 10/3. So subtracting 10/3 from both sides, we'll subtract it over here, and we will get b. So finding a common denominator, so what do we have? Negative 18 minus 10 over 3 is equal to b, so that should be negative 28 over 3. So b is negative 28 over 3. So now what is going to be the equation? Well, we have it right up here. Y is equal to mx plus b. So that's 5/3 x plus this b right here. So we have y is equal to 5/3 x, and then plus this, which is minus 28 over 3. Okay. Now we have a little application problem. So in an aerobics class, the instructor indicates that her student's exercise heart rate is 60% of their maximum heart rate, where maximum heart rate is 220 minus their age. So we want to determine the equation that gives the exercise heart rate E in terms of the age A. Okay, so what was told? So the exercise heart rate, so that's E. So E is, so it's equal to 60% of their maximum heart rate, where maximum heart rate is equal to, so okay, what do we have right now? So we have E is equal to 60%, so that's 0.60, or you could just put 0.6, times the maximum heart rate. Max heart rate. Right? But what is the maximum heart rate? That is told to be (220) minus their age. And the age, we're told, is the variable A. Okay? So that's basically it, but you could simplify it a little bit. We could distribute in the 0.6, and so we will get 132 minus 0.6A. Okay, and if you look at this, this is actually a linear function, right? Because comparing it to f of x is equal to mx plus b, what we actually have here is E is in terms of the age, right? So we actually have E, the exercise heart rate, is in terms of the age, and that would be this negative 0.6a plus the 132. So just so you could see how this compares, right? In this case, the variable is the age. The function is the exercise heart rate. Okay, and then use the equation to find the exercise heart rate of a 22-year-old student. So how do we do that? Well, 22 years old is the A value, right? So this is A, and all we have to do is just substitute that in, okay? So E substituting in for 22, we're just going to replace A with 22, and that's pretty much it. So 132 minus 0.6 times 22. So this is 132 minus 13.2. So we are actually getting 118.8, and this would be beats per minute. I guess if you want to round up, you could say it's 119. All right.